I'm here with Bill and Sue Easter, who have just recently had a great success story in front of the North Dakota Industrial Commission. So I would just like to let you guys begin by talking about what your project is and what comes next, and how you got to this point in having a successful vote in front of the North Dakota Industrial Commission to fund your project. So what are you doing with your project?
Well, we're actually taking two waste streams, CO2, gaseous CO2, and we're taking water, they call it produced water, that comes from oil and gas exploration. So when you get a barrel of oil, you get approximately another barrel of this produced water, and it's a waste stream. They pump it back down in saltwater injection. So the idea was sort of to take these two waste streams and turn them into a particle. And so that particle is sort of an intermediate that we use we can make a whole bunch of other products. So I think there'll be a lot of products, but it starts from this sort of intermediate, and it's a mixed carbonate. It's a carbonization product. And it's sort of interesting, Jason. We were listening to the DOE today. They have their.
I was wondering if you were on that. Yeah.
Big meeting. I wasn't. I was listening. I didn't make the big. I didn't make the big time there, but they were talking about the CO2, carbon, and what looks the best for them. And they talked about mineralization. Looked like it was far out ahead. Well, that's what we're doing is mineralization. And I'll put another plug in because you asked me what we're going to do at the end, but they have these grants. They're called carbon utilization procurement grants, where if you can show that you reduce the carbon footprint, that they actually will buy products and subsidize them, and states and local nonprofits can do that as well. So I didn't want to forget that, but that's a really important. And then when you take these carbonates, you don't want to leave them like that. You want to put them in something. So we have made panels out of this. We've actually filled plastics out of it. And so it's almost like this is a man-made carbonate. And so if you look for an analogy of it in nature, it would be limestone. So it's calcium carbonate, and it's actually the material or the mineral filler that's used most in plastics. So you look at where this could go. It could go in all kinds of plastic operations, and it could go in building materials like what I showed you. And I think it can be an aggregate as well for concrete. So It's really exciting. It's what I like about it. I think we're going to be cheaper than everybody else too. So they have these. I mean, they're talking $600 a ton, $500 a ton. And I think ours is a very pragmatic way of doing this. We bubble the CO2, and we make the produced water basic, and so out drops these calcium carbonates, and we keep making it basic. And you can actually get the base from some of the other elements in the produced water too. So this could be a really self-sustaining thing. So I think we're really at the beginning of it. I think the water is a tremendous resource for minerals. And then, I was also listening to them talk, and they said, well, we're not sure you can do this out of flue gases, or, can we do this with. And so part of what North Dakota is paying for us is, well, we think we can, or my scientists think they can. The EERC, who's worked with us, they all think that they can. And so this would really be cool for coal power plants, right? So that we would be able to take the CO2 off of that. So I think energy, we need energy. People are concerned about the environment. We want to be respectful of that. So if we can sort of combine these two ideas together and, let the technologies keep going on, while because we definitely need energy. And, where are we today? Where will we go? And, I think this could be a great, thing, and CO2 comes off ethanol plants and ammonia plants. So it's not
Right.
it's not just power plants. So it comes off a lot of different things. So I think this is really exciting, and we've really enjoyed working with the EERC, the Lignite Council, the people of North Dakota. So we've done other projects that you guys have supported. We're actually building a. So what we're kind of known. This is sort of a new thing, but we're known for taking lignite and turning it into building materials. And we're actually building a building, and that should be completed in the spring. So
and you're going to be able to transfer, kind of put that on a truck bed or something.
So it's kind of, so hopefully, I don't know if Mike Holmes or who's going to drive it up here, or, get it.
We won't do it in winter.
Right.
We might wait till the spring to get it up here, but I think, there's, and again, people have different philosophies on these things, and, we're kind of pragmatic. We can work with coal. We can work with the CO2. We can build different material systems depending on what people are looking for, really.
And that's kind of one of the interesting things about what you're doing, both on this most recent project, but on your panels as well. It's not like you're inventing new materials per se. It's not like we don't already use these components. You're basically just coming up with alternate sources for these, especially the calcium carbonate, the limestone. Like, we're already doing this, but what you're doing is finding an alternative source for that building block for those particular materials.
Right. You're definitely right. And part of it is, they're putting incentives, so what you incentivize happens. So they're basically saying, look, we'll pay you to sequester this. And the cool thing about, people don't know limestone or CO2, it is sequestered. It does for, boiling water is 100 C, so 600 C is 6 times boiling water. This CO2 is going to stay in there, so it's not going to come back out.
It's 30%.
She's right. So basically, 30% CO2 gas is sequestered in this thing. And other people are doing products, and we're hearing 2, 4, 6, 8%. So this seems to be a world beater on that metric as well.
Well, yeah. And, one of the things that people do realize, those folks who are looking at CO2 emission reduction, that wood is a sequesterer of CO2. And we've used wood as building material for a long time. But if you were to compare the amount of CO2 that is sequestered in wood building materials versus what you're doing, again, you're sequestering more CO2 by an order of magnitude.
There's a lot of CO2 sequestered in wood, but I think this is actually more permanent. And the CO2 will, the wood will eventually. Disintegrate, turn into other products, and oxygen, it's powerful. It will oxidize and rust and do what it does, right?
Well, it's one of the things you said was really interesting, because you talked about, you'll end up with those things that you incentivize. And again, one of the things that is interesting to me about this project is we have created a regulatory framework where we've looked at produced water as a waste. We recognize CO2 as a waste. And traditionally, we focused on waste disposal and mitigation. And while we still have to do those things, how cool is it that this framework exists where you can say, is that waste disposal framework the only one that we can look at these things through? Is there something else? Because we're producing these waste products as a way to maintain our daily lives. And to take that opportunity to do something is amazing.
You want to get in that circular economy where you're using it, you're reusing it. So.
And I'll throw this out again, Jason, is so the government actually is, the federal government has these carbon utilization procurement grants. So we could, let's say the Heritage Center or the state capitol, you say, okay, I want to put some of these panels on there. They would give 50%, so they subsidize it by 50%. So they're trying to get, they're trying to incentivize, get this stuff going. And I think in some cases we're ahead of a lot of other people. And, there's opportunities. You could actually build paint out of it, believe it or not, like road paint, because, so there's CO2, there's carbonates in some of these paints. And so you just replace the natural one with a sequestered one. So again, they would give you the credit for taking the CO2 waste and putting it together. In the produced water, I see it as this is just the beginning. There's all kinds of other elements in it. I mean, if you look at seawater, I don't know if it's 10,000, 20,000 parts per million.
Yeah, so before you get to that, because I think what was really, you gave a great description of what produced water is when you were at the Lignite Research Council a couple weeks ago. And so as you kind of continue that thought, why don't you give an explanation of where we get produced water and what it is? Because
sure.
I don't think people understand the difference between produced water and frack water. And, especially then you're starting to talk about stuff from our industry like the flue gases. So as you make that explanation, if you'd make that clear as well.
Sure. So if you think of it, it's like geological water. It's been down there a long time. And so lots of minerals have come up into them. So it can be in the order of 200 to 300,000 parts per million. So whereas regular salt water, or you go to the beach, it's 10,000, 20,000, depending. So it's just, and so people deservedly don't want it on their land, right? I mean,
Right.
it's so they shoot it back down with a saltwater injection. And so some of this in certain areas, I don't think necessarily in North Dakota yet, but in some areas, they're getting earthquakes from the salt. They're not getting earthquakes from the fracking. They're getting earthquakes from the saltwater injection of this produced water. And
that is one of the things that in North Dakota, because of our geology, we have not and will not have that issue.
Right.
But we do have the abundance of the produced water. And you say, what can we do with it that is maybe positive?
And I actually believe that you can take this with the proper, this step that we do actually unlocks the other elements, because the calcium, magnesium, and strontium is what, starts clogging up and deposited on your pipes. That's like hard water and stuff. And so if you take it out, then you can kind of unzip the other elements out of it. And there is stuff like lithium, the things that people are talking about with these EVs and stuff. It's
Yep.
in that produced water. And so is there a way to mine it? So it's very thermodynamically accessible, much so than a mine in some ways for some of these elements. And so this thing that you think is terrible or people think is waste could be, like go back to the buffalo and the Native Americans, what they did with the buffalo. They took every piece of it, the bone, the skin, everything. And so the produced water, you could take all the elements out of it and then use it, irrigable and then, for crops and stuff. But you could say, hey, look, can I get to the end where I could actually use that for people potable water? And so that will take a while to get there. But you can see the magnitude of it. It's unbelievable how much water it is, right? So it's sort of like for every barrel in North Dakota, for every barrel of oil, you get a barrel of this produced water. But like places like Texas, it's 5 to 10, and sometimes, and they don't have the resources that you guys do. They don't have the good water that you have.
And that's one of the things that we've talked about in energy production for 15 years now, is this nexus between energy and water. We have to do a better job understanding the interrelationship of those things, because while in North Dakota, it's not a concern that we are like in a water shortage, but in other places of the country, how we reconcile the water needs with energy needs with population needs is critical. And so you kind of got to give props to DOE for recognizing, hey, let's at least evaluate how we can use these things that aren't being used yet, because there's opportunities there. And
Absolutely.
Even if right now, that we're not getting to that point of potable water, we're learning about what the status is and what it takes to get from here to here, but we can still get value out of going from here to here. And that's where this is just one point piece of the puzzle.
Absolutely, because you're going to have CO2. You can't not have it. I mean, if you're going to make fertilizer, you're going to make ethanol. There's certain
if you're going to breathe.
So you have to have it, and power plants, fossil fuel power plants, you have to have CO2. And so if you're going to go for oil and gas, you're going to have produced water. So what can we do with it? How do we turn what looks like a negative into a positive and, unlock the mining? I mean, wouldn't it be cool if, the magnitude of produced water, people have no idea, but what if we could solve a lot of our mining needs for some of these elements, and we didn't have to dig it in Africa, or we didn't have to do, that we could get it from.
And it's U.S. sourced.
It's domestically sourced, which is
already
becoming
very
there.
We're looking at it. We've got it in our hands. That's where it's kind of interesting. So when you were at the LRC, you described this, what sounds like a relatively simple cycle, where you're getting the water itself, and then you're getting the gas, and you're just bubbling that up. That doesn't sound like it's a terribly energy intensive cycle. What is the energy intensity of something like this?
It's
especially
pretty low.
compared to like
we don't even have to boil it, so it's 70 C, 80 C, so it's not, and boiling water is 100 C, so it's not that bad, and it's not that, and so again, if we can take, if in a perfect world we get the base and the acids from the produced water, and so you have this self-sufficiency, perhaps you very small modular chemical units, rather than these monster factories that have potential pollution things associated, explosion things. You have a very sort of modular approach to it, and whoever's in the area, you could use that water, right? And it's funny, Jason, while I was at the meeting, people were talking that they have some waters that have these high levels that are associated with some of their ponds and stuff, and I go, this would be great, you got the CO2 and you have the water right next to one another. So I think there's more than just I think produced water is of a magnitude and certainly interest, but I think there are other waste streams that we could use as well, and we just have to study it and try it and see what happens.
Yeah, and that was getting back to what the meeting was earlier today with the Department of Energy. They talked about the benefits of mineralization, and then there was that skepticism about, hey, can you really use the flue gas as part of that mineralization? So that's one of the reasons why we, as the Lignite Council, are interested in this technology, because DOE isn't there yet where they're going to say, hey, this is, part of the solution for flue gases as well. We're trying to build up the state of the science by saying, let's solve that question. Let's give some data to DOE. So as they're talking about mineralization, they're also talking about flue gas.
Correct.
And what is the source of your CO2 that you're going to be bubbling through your project?
So we'll be working with the EERC. We'll mimic coal plant plus other sources. So I don't think we'll just limit it. We'll with the beginning of this. So at the beginning, you get a little money, and then the next phase two, you get more money, and you can put it closer to the source of things. So.
Right. And didn't you say at one time you basically hooked up the exhaust of like a diesel
We did.
pickup
So the original stuff, one of my crazy scientists, he hooked up his pickup truck and he got a tow to produce water, put some base in, and then just bubbled his exhaust through it with a little dispersant media. So yeah, I mean, going back to North Dakotans and how pragmatic that you are. I mean, people didn't think fracking was going to work either, and you're one of the places that really got it going. And a lot of skepticism, and it's never easy, doesn't happen overnight, but you have to go at it. And, I think North Dakota has a history of being successful with things that people are a little skeptical of.
I think so, yeah. So I know we're approaching up on that half hour that I kind of wanted to stick to. So I got two more questions for you. One of them is what comes next for you? You've kind of said there will potentially be a scale up at some point, but you got to continue to fine tune the data and the operations. So what is next?
I think that is what's next, but I also think you have to look. We are business people, so where can we sell this? Where does it fit? Where does it go? And again, incentives drive things, and so they are incentivizing. I think they believe, the DOE believes, if you could get to $100 a ton cost, I'm hoping we can beat that. So we can
now,
make
what would
money,
that refer to? Does that refer to the carbonate itself, or
so if I want to take CO2 from either, I think it's from a direct source, and I want to sequester that or put it away, that their kind of metric, I believe, is $100 a ton. So,
got it. So that's
if we can
basically
beat
the 45Q number,
correct,
like
and
85.
and so they give you maybe $65 a ton if you put it in a product like we do, or $80 a ton if you can put it down in like one of your formations, that geologic formations, and then direct air gets more, different sources of it. You get different incentives, but so if we can get it, the cheaper that you do it, the better off you are, right? And especially if you can sell products. So in a perfect world, you're able to use a subsidy as you kind of scale up, and then subsidies go away. So you have to have something that has enough value that it doesn't matter. You do it anyway. I mean, so
you can still compete in that market.
Yeah. You do it anyway because you're making money.
So good. So last part is, rather than begin with this intro, I wanted to end with it because it comes into my last question, which is, you've talked about where you get the produced water, talked about the source of CO2, but you haven't talked about the most important part of that, which is, who are you guys and what are you bringing to that equation to make that magic all happen? So I wanted to be able to say it's not just mixing things. You're adding your own intellectual project or property research and development and expertise to this process as well.
Sure. So in every project that we've worked, and we've had several with North Dakota, we bring an inorganic polymer that's has high performance and is inexpensive. And so that's what's gluing these particles. So we have these particles that we get from the produced water and the CO2, but then how do we make a part? And so that's what we're providing, is that technology. And it's similar to, it's a little different, different families and varieties, but it's the same thing we did with the lignite coal making parts as well. So, and, I wanted to, again, I brag on North Dakota. You have supported us. We're in Florida, but we've gotten the support from North Dakota. I don't think we get the same support in Florida. In fact, I'm pretty sure of that for some of the projects. I think it's hard for people, coal, CO2, they don't necessarily give you a chance to, hey, let's talk about it. Let's see what we could do. Yeah. And I think there's a reasonableness, pragmatic, hardworking, high integrity. My line on North Dakota is your best resource is your people. You may have all this oil and gas, and you may have all this coal, and you may have all this land, but at least the people, either all we're meeting is the best people you got, which it could be, that you're doing that, but we've been impressed. I mean, it's
well, and I would say our company has that in common, is that our strength is our people. We have a great team of scientists, and everyone has different talents, and we work together well. I'm a counselor by trade, so I've been sucked into the scientific world. Yeah. But I second that on North Dakota people. Y'all have been welcoming, and we really like North Dakota and would love to contribute some way.
Yeah, it really is our strength. So end with the plug for your company, and then we can just go ahead and conclude and tell a little bit more about your company itself.
So the company, multiple companies. We're parent company is Semplastics, and we're involved in semiconductors, have been for 23 years. We're now moving into the materials, been doing that for 12 years. I actually did it my whole career is in materials. And our goal, is, powering each company to achieve market dominance by creating customized, sustainable materials. And so whoever we're working with, we want to give them a solution that they dominate a market so they make money. I mean, it's because if you're only living for subsidies, that's the short term. That doesn't work. So you need to have something that creates high enough value that, your customers can get paid, employees can get paid, vendors can get paid. And so we're taking things that are very low cost. Lignite coal, you can't beat it. I mean, I don't know if it's a penny a pound or a penny, whatever that is. And, waste products, well, they're negative. They give you money to take them away. So if we can take those things and turn them into high value products, that's how we've been successful. That's how we're making our customers successful.
Yep. And that viewpoint there is one that is critical to success, I think, in North Dakota and elsewhere, which is, looking beyond that subsidy, looking beyond that, because ultimately in North Dakota, we're trying to build the next generation of lignite-centered facilities, continue the work in the ag and the energy industries, and we have to continue to add value to the economy. And, that does require some investments from time to time, but that awareness to go back and say, that's not the answer, though. That is a part of the solution, but long term, everybody's got to be a winner here. So I appreciate your observation there. And did you guys have any other things you'd like to add?
I don't think so.
No, thank you again. We really appreciate North Dakota, the NDIC, the governor, everybody supporting. North Dakota is a can-do state and a business state, and so even though these Floridians get a little cold when we come up, it's worth the trip. It's worth the trip.
Very good. We're glad to have you. So thank you for joining me today and just talking a little bit more about that project. So thank you.
Thank you.
Thanks, Jason.